in here. So what we need to do is we need to make an array, maybe even a parallel array, so that we can find maximum and minimum out of it. And we could step through the PowerPoints and find that code there, or we can just jump right in and do it. So I'm going to make a new project. Add a new file. And it would be fun to generate random data. Nah, but I don't want us to have to sit here and type in a whole bunch of data each time, so we're only going to make an array that's like 4 pieces long. I'm lazy, so I'm going to find my boilerplate. Encourage you to do the same. So, allocate our arrays. We're going to be calculating some students and then some numeric data about them. So, we're going to need a string class. So you # include string, tack that on. # string. Make sure we have that. Let's create an array of strings. To create an array, I give the data type and I give a name. Names for students. And then what do?
Bracket?
Yeah, I got to use square brackets, and I could either specify a list of names or I could specify a length and then go in and fill the names in one by one. I'm just going to specify a list of names. So I'm going to leave the number between the brackets out. That will be determined by the data that we pass in. And then give yourself 4 names. Bob, Kelly, Sarah, and then Tara. Then we need some numbers. Ints, floats, doubles, something. Int height. Well, if we're going to do height, let's do doubles. Heights with an S because we have more than one. Or we could call it height array or something like that. But anyways, this needs to be the same length as the list of names. I could hard code it to 4. I could count the length of the names and allocate it to that. That is what I'm going to do, and I believe I demonstrated that last time. It needs to be a constant. Pardon me?
We need to make a constant double, don't we?
We got to make it a...
Why is heights highlighted?
Because I didn't finish typing it.
Oh, okay.
It's a syntax error at this point. So constant num, max num, something, max array size is equal to, and how do I calculate how many elements are in that array using the size of operator? I'm going to do size of, but what I want to take the size of, the array itself, divided by the size of each string. Or I should say the size of the string class. And I type size instead of size of. And I forgot to give this a type, so it's underlining it, const int array size. Because an array has to be an integer. You can't have an array that's got 3.9 elements in it. All right, here we go. Double heights, array size. I want to check something. This syntax works in some languages. I do not recall if it works in Java. That would zero out the entire array without need for writing a loop to do so in some languages. I'm going to try it out here. Pardon me? Don't think it works. Let's find out. For every let's not get fancy. Yeah. For int I is going to be my iterator, equals 0. I is less than the array size. I plus plus. This is just a test. See out the heights at that position, I followed by an ENDL. I'm curious about the contents of that array now that I did that. I want to see if this works. It did. Well, what do you know? Okay, that's a short syntax for clearing out an entire array without using a loop. Well, I'll be dipped. Okay. How to zero out an array without a loop. We're giving it an initializer, but we're giving it only one initializer, one value. What would happen if we made that a 1? What's the rest of it going to be? I'm just experimenting at this point. 1, 0, 0, 0. So it fills in the first value, and then all the values after that get filled in with 0, which is just what we want. We want them all to be 0 before we start doing stuff with it. And why is that? Because an array, once allocated in C++, unless it's allocated in a specific location, is full of garbage data. You have to zero it out if you want to be sure that you have valid data in it at all times. All right, we don't need this for loop here, but we're going to use a very similar one for our data entry. For int I, or int x, or whatever your favorite counter variable is, I is less than array size, I plus plus. This is going to make the homework very easy. Just saying. All right, see out enter height of, or enter height in feet of, and let's print that person's name out. Names, and then followed by, you know, a colon or something so that they know where to start typing. We need to get that input. Double height, CIN into height, and then we need to store that into the array. I don't want to use the variable height, I'm sorry, because I already used heights, and I don't like using two variables that only differ by one letter. So let's call this one HT, or feet, or something. And then CIN into feet, and then we're going to make heights at subscript I, square braces I, equal to the feet that they typed in. Now, did it need to be so long? No, we could have skipped that part and we could have just read directly into the heights array. I'm almost thinking I'd rather do that. This would be great if we had to do some conversion to it, like convert it to integers or something, but I'm going to delete those 3 lines and just read in directly into the array like this. CIN into the heights array at position I. Simplest code. Now we have some data. Let's find the minimum and the maximum height. And let's also find the index numbers of those. So we're going to be keeping track of 2 things, really. Why the index number? Because if I find out that element 3 has the highest height, I also want to know the name of the person who sits in element 3. So we have to have an index number so that we can access both the height array and the name. Alrighty, so we're going to write a loop. I guess we ought to run it and make sure this works. No syntax errors. Enter the height and feet of Bob, 12. Kelly's 13. Sarah's 14. She's pretty tall. Tara is 5 feet tall. There we go. It doesn't do anything right now. It's not even printing the data. We didn't throw in a print loop. This is most of a print loop, but it's not printing out their names, so it's kind of lame. Now to figure out the max value, if you're coding it yourself and not relying on a library, what you got to do is you got to start from the beginning and keep checking until you find the person with the maximum value. So I'm going to walk along. I'm going to ask your age, and you can make up a number or whatever. What's your age?
30.
You're 30. You're 0. Now I'm going to go to number 1. What's your age? 50. Okay. So your element number 1, I'm going to erase that 30, and I'm going to write 50, and I'm going to write the 1 down so I can keep remembering that. What's your age?
22.
22. You're not higher than 50. Nope. What's your age? 22. Okay, somebody pretend they're older than 50. Over here.
65.
65. Okay, now you are the max. So I'm going to write 65 down as my max. And we were at number 0, 1, 2, 3, 4. So you're index 4. And I'm going to keep going like that until I'm at the very end of the array. And I should have a maximum height. And I should have the index number of the person with that height. So we need 2 counters. We need one called max h or max height or something like that. It has to be of the same type that our array is. Double max h. And we want to set it equal to the first value. Or alternately, you set it equal to the smallest number in the universe, like 0 or something like that. But why don't we just say it's equal to heights, position 0, the first person in the array. And we need to set our index value, the max I. That's an integer though, because index values are always integers. Max I is equal to 0. That's where we're starting.
You could use max and minimum at the same time.
We could do them both, you're right. I'm just going to do the max now, and then I'm going to go back and check those and add those in. Sometimes people like to do them in 1 loop, sometimes people like to do them in 2 loop. I think we may as well do it in 1. But we're just going to solve for max right now. So we need a for loop. For int I is equal to 0, I is less than the array size, I++, if the height of the person at that specific index is greater than our max, max h, that becomes our new max. Max h is equal to heights at I. And then we need to keep track of that location as well. So max I, our position, is equal to I, so that we know where we found the largest value. I'm going to scroll down a little bit and just print that stuff out. Cout max height, and then max h, followed by an ENDL. Cout at index, arrow, arrow, max I, ENDL. And I build errors. Apparently array size is not the name of my constant. Okay, I need to take out the underscore. Pardon me. All right, enter some test data. Once you get it to this point. Five, 6, 4, 4.5. It says the max height is at 6 at index 1. And is that true? Was the 6 at position 1? Well, what was the first one I entered? I entered 5, so that's index 0. 6 is index 1, 4 is index 2, Tara is 4.5, so the maximum height was at 6. Now when I go back and I print the name of the person who's 6 feet tall, we've got kind of a little bit of a bug here. It's only going to print the last or the first person of that height. If you're worried about that, think about how you could fix that. You would use a loop to print it out. But let's go ahead and print out the name of the person. We have the index number because remember they're parallel arrays, matching the name and the height, the name and the height, the name and the height. This isn't the world's most informative message, but max height at index is, and we're going to print out their name. What was the name of the name array? I think it was just names, right? Names, parentheses, max I, followed by an ENDL. And as a matter of fact, I'm going to take out these other ENDLs and change the spacing a little bit to make it look good. Like that. That way it just prints it all on one line. Builders. I forgot my semicolon. Bob is 5, Kelly is 6, Sarah's 4, Tara is 4.5. Kelly was a 6-footer, so this did work. How would you do the minimum? You could write another loop, or you could just add a couple more things to this same loop. What are you going to do that's different? You're going to declare a minimum height and a minimum index. And instead of saying if heights is greater than max, what is that line going to look like? If heights is less than min. I think I'm going to go ahead and make them 2 loops. But you can combine all this stuff into one loop. And if you grasp that, then please do.
Can you use an else?
I wouldn't want to use else. But I could just put it right here. If heights is less than min. Oh, let's do it all in one. Okay. So we need minimum h and minimum I as well. I changed my mind again. I want to do it with 2 loops. I apologize for that. If you know how to do it in one loop, go ahead. So double minimum height is equal to the first position. So that's heights, and what is the first position? It's at index what? 0, yeah. And then integer minimum I for the index is equal to 0. Why am I getting an underline there? Okay, good. Now I need that for loop again. And to be honest, it's so similar to this that I'm just going to cut and paste. Copy all that for loop. Just highlight it all, Control C, whatever, Command C, go down here, paste it. But this is a line that changes. Instead of if heights is greater than max h, make it if heights is less than minimum of h. And if that's true, then that becomes the new minimum. And the minimum index is equal to that position. Then we need to print that stuff out again. So I'm going to copy those 3 cout statements and change all the maxes to mins. And you could honestly even calculate the sum in the same loop. You could combine all of this stuff into one loop. I'm going to use the same data. Change it up a little bit. 5, 4, 6, or 7, 6. Sarah is 7 feet tall. It found the maximum of Sarah. Kelly is the shortest at 4. It found her too. What happens if they were all 7 feet tall? Besides the fact that we apparently have a race of aliens. Let's do 7 feet here, 7 feet here, 7 feet here, 7 feet here. The max height is Bob, the minimum height is Bob. Is that quite accurate?
It's not inaccurate.
It's not completely inaccurate, but a superlative implementation of this would list everybody who had a height of 7. So you would just need to loop through the list again, finding everybody whose height matches 7, and then print that index out right then and there. But we're not going to do that. That wasn't required of the assignment. So I hope you see how applicable this is to the rainfall assignment. Is that strings have been, the string class has been written in such a way that it can be indexed like an integer. This is totally not part of the assignment that we've just done. You may as well stick this up at the top because we'll probably wind up deleting it in a minute. But up here, do this. String name is equal to, and put a name in, Bobby. And then see out the first letter of that name. Name, parentheses, 0, followed by an ENDL. It should print a B. See out the second letter in the name. Forgot my semicolon. And so on. We could go all the way to the end, but you know, just printing 2 is enough proof of concept. So, there we go. Now, is a string really an array? No, it is not. What they have done to get this to work is a fairly complex topic that I'm not sure we're going to hit, called operator overload. This square brackets here is an operator, just like the plus sign and the minus sign and stuff like that. And when you write a class, you can say what you want the square braces to do, and what you want the plus sign to do, and what you want the minus sign to do to that data. So they've made it so that you could pretend it is an array. In olden days, an array, and I mean, and this is still true, could be a character array. And I would probably botch this if I try to do it. Character school, parentheses in parentheses, is equal to rows. Now print out the first and the second letters of that string. See out school at position 0. And then copy and paste that to do position 1, 2, 3, and 4. Go all the way out to 5. So 0, 1, 2, 3, and 4. There we go. Is that string even 5 letters long? Well, it doesn't look like it. Looks like it's only 4. So is it going to crash when it hits that last one? No, it is not. And those of y'all with previous programming experience probably know what is that position for in that string. Anybody know?
End of line, isn't it? Or-
It's not an end of line, but you've got the idea. It's an end of string indicator, which is the
Yeah,
null.
string, yeah.
Okay. I didn't put ENDLs. I'm going to go ahead and add some ENDLs with a little more judicious copying and pasting. Okay, so Bobby, Rose, R-O-S-E, and you see that it printed out some kind of blank here. Let's find out what those numbers are. Copy that code, paste it, but in front of each one of these things, put parentheses INT. We're going to cast that character to an integer so that we're printing it out not as a letter, but as the ASCII value of that letter. I'm kind of getting tired of seeing that BO at the beginning of it, but here we go. We're seeing ROSE, and R is an 82 in the ASCII character set, and O is a 111. I've used the term ASCII and we've pulled up the ASCII chart before. Is that correct or not?
That is correct.
Okay. And then an S is a 115, and E is a 101, and whoops, there's a 0 at the end. That is by design. When you declare a character array like that and you store some text data in it, 0 indicates where that text ends so that it knows. So that you can write a for loop that'll print that string out or process it. And you just keep going until that character is a 0. Yeah, I guess I actually want to demonstrate that. Let's write a for loop that will step through that school. Nah, we're not going to even make it a for loop. We're going to pretend that we don't know any way of getting the length of the string. So we're going to use a while loop. I need a counter. I'm going to call it X since I think we were using I down there. I is less than 0. And while the character at that specific position, X, while subscript X, is not equal to 0, we're going to print that character out, followed by some groovy thing like an asterisk or something like that. So print out school sub X, followed by, space is good enough, isn't it? And I forgot to put my opening brace and closing braces. We need those. Since this is not a for loop, I'm going to have to put an X++ inside my loop. So it'll take a little bit of editing to get that, but there you go. And then let's print out a blank line at the end. Not a blank line, but a character turn, so that we write all this stuff out. What this is doing is it's stepping through that character array, printing out each letter followed by a space, and then when that value is done, because it finds the null, the 0 at the end of the array, it stops and we'll print a blank line. And here we go. It did print rows separated by spaces. So this is an example of a null terminated string in old school parlance. Back before C++ and fancy classes like strings and stuff like that, you did an awful lot of stuff with character arrays because that was how text was stored. And you'd write functions or use functions that would copy the text from one array to the next. You know, you had to do a lot of that stuff. Now you spend a lot of days in class learning about how to manipulate these kind of things and write, you know, efficient algorithms for removing things from a string or things like that. So I guess the last thing I want to demonstrate is if we wanted to copy the data that was in this array and put it in another one. Let's do that. Again, I'm going to pretend I have no idea how long that array is. And so I'm going to make it arbitrarily large. What I mean by arbitrarily large is larger than my expected value for this. And this is really bad programming. I'll tell you why in a minute. But let's make a new array. It's still going to be an array of characters. I guess I'll just call it copy. Or, yeah. I guess that's a good enough name. And I'm going to make it 80 characters long. Why 80? 80 was a commonly used limit for arrays like this, just on the assumption that screens at that time, monitors, were 80 characters wide, and so no one would ever type in data longer than that. Is this a good way to do this? No. I should allocate the array to the exact length that is needed. So I should use some kind of function that will search that array. I believe it's just called string len, and tell me how long it is, rather than hard code it to 80. But I'm going to go with this. Now we're going to copy the data from the school array into this copy. So we're going to reuse our x counter. X is equal to 0. And while school sub x is not equal to null, I'm not liking this because that's not going to copy the null character as well. Let's use a do loop. Did I mention a do loop when I started talking about for loops?
Yes.
Alrighty, so do this stuff. Do copy at x is equal to school at x, and then increment x, and keep doing that as long as, or while, school sub x I've got this botched. So if I step through this in my mind, it's going to copy the R. It's still not going to copy the null. I could write a much nastier version of it. Character CH, I'm rewriting it and I apologize for that. Character CH is equal to school at that position. Now that's not going to do it too. And as a matter of fact, I'm going to skip this step of it. I'm going to go back to doing what I originally had planned. So forget all of that. I apologize for going off on that lead. I can't believe that I've forgotten how to write a simple null terminated string copy. It sounds like you know. Scroll down to the bottom and let's make a copy of the heights array. That one's easy because we do know the length of it. Array size. Now I could have solved my problem up there just by keeping track of how many letters were in it and then making my while loop go up to that. But so down here at the bottom, let's declare our new array. I don't know what to call it. So double new heights is equal, whoop. And then inside the square braces, we're going to go to array size again. And now we can use a for loop to copy all the values from one to the other. For int I is equal to 0, I is less than array size, I plus plus, and inside our braces, new heights at that position is equal to the old heights, just the word heights at that position. And you see what that does? That just copies each element in turn, 0, 1, 2, and 3, from the old array into the new array. Is that part of this assignment? Not really, but I want to demonstrate how to copy code. So I'm going to put a comment here. Demonstrate how to copy an array. I'm going to scroll up and put a comment here that says demonstrate how to find the minimum value in an array. And I should scroll up even further and do the same thing for the max. Okay, I want to check something. Un momento. All right, I think we've already talked about everything that's in this PowerPoint, even though we've only looked at 10% of it. No bounds checking in C++. What does bounds checking mean? It means that it's not going to give you an error if you try to go past the end of the array. And by the way, I said that I'd tell you what was wrong with assuming that the maximum length of the array is 80. What if somebody found a way of entering 800 characters and then tried to copy it into that array that was 80? You'd wind up writing over all the data in your program and writing into the executable part and maybe writing into the, the program after you that's sitting there ready to run. That's called a buffer overrun. Lots of bugs, viruses, worms used to rely on that idea. And for all I know, they still may, although people code things a little bit better. String classes don't lend themselves to things like that anymore. The very first so-called internet worm, back in like 1987 or so, was written by a guy named Robert Morris, and he wanted to map out the internet as such that it existed, all 100 or 200 machines on the internet at the time. And he found a bug that he could exploit in the mail programs that all the computers were running. And all those computers had a mail program, all these Unix computers had so that if you opened a connection to it and then fed it too much data into a string that was expected to only be 80 characters long or something like that, then you could get control over that program, write something out to its hard drive, and what that something he was writing out was the same program that would then go and contact another computer. And he made a little bit of a bug. It was supposed to only run once and then stop running, but instead they just kept looping, reinfecting each other over and over and over as fast as possible, and so it brought the entire internet, such as it was, down at that point.
Wow.
So that was called the first internet worm. Robert Morris was the son of the director of the NSA at that time, also named Robert Morris Jr., Sr. Can you imagine going, Dad, I crashed the internet, having to tell them that. He was a guy at Cornell, so, he probably didn't get grounded. But anyways, that was before things like viruses and worms and Trojan horses and stuff like that even occurred in anybody's, the public consciousness at all. So no bounds checking means that C is happy to let you check, we had heights. Valid values were 0, 1, 2, and 3. You could try to print out heights 4 or heights 4,000 or 4 million or whatever. And C++ is not going to stop you, even if it causes your program to crash. So C++ does not check it to make sure it is a valid subscript. If you're using a string class, since it's a class and not a raw data type like the array, I bet it does. So here the following code defines a 3-element array, but then writes 5 elements to it. Notice this: constant size, values, array size, int count. I will store 5 numbers in a 3-element array. For count is equal to 0, count is less than 5, write out the value 100. So that writes 100 into this position, this position, this position. That's as long as the array is. Whatever variables are declared after that array are what are going to get erased by the next 100 and the next 100. So data is being corrupted even if it manages to not crash the program by sheer luck. So you have to be careful not to use invalid subscripts. You can corrupt other memory locations. You can crash the program. You can even lock up the computer. That's not likely anymore. Operating systems are more secure than they used to be. It should just terminate the program. Off by one errors. Off by one errors happen when you think that array starts at 1 rather than 0. Here we declare an array that's 100 long, and we start writing. Okay, I'm 1, 2, 3, 4, all the way out to 100. Set all those to 0. That's great, but what's the first position in this array really? It's not 1. It's 0. And are you supposed to go out up to and including 100? No, you're supposed to go from 0 to 99, which is still 100 numbers. So that's an off by one error when you use 1-based indexing rather than 0. Array initialization. We have demonstrated that a couple of times, I believe. Like that. Use the curly braces. You fill in the numbers like that. Notice that they are specifying a size here. You could leave that off and it just assumes that the size are the number of elements in the initializer list. But you can also specify the size. You could say I want an array that is 100 elements long, initialize it with these values, it'll fill in those first 5 values and then the rest of them will be 0. That's the trick that we used to zero out our array. But the initializer list cannot exceed the array size. If you make this thing say 5, but you put in 10 there, I don't even know what it'll do, but it's not valid. Partial array initializing. If you have a partially filled array, that means that some of the array is good and some isn't. What if you've written a rainfall program? It's got 12 values. So far, the user has only entered the first 4 pieces of data. 1, 2, 3, 4. The rest of it does not have valid data. So if you were going to write a program that at that very instant needed to go through and calculate the average rainfall for the data entered so far, it better not go all the way to the end, or else these zeros are going to bring it down. You see what I mean? If you only have data for the first 4 months of the year, you can't add those up and divide by 12. You can only divide by 4 to get the average rainfall. That's called a partially filled array. When you're entering data, if there's a chance that it's a partially filled array, you need to keep track of how many elements you have filled up, so that later on when you print the array out, you don't print the rest of the elements. So we could write our loop in such a way that each time we put something into the array, we increment a max data counter or whatever, so that we would know, oh, by the way, I've got 4 pieces of data. And then when we were calculating the average, we would only go out 4 elements. Or when we were printing them out, we would only print out the first 4 elements. Implicit array sizing. That's when you leave off the number between the square braces. The compiler goes, oh, you need 4 pieces of data, I'll make the array 4 long. And you say, thank you. A range-based for loop. Every language calls it something else. This text calls it a range-based for loop. I'm going to call it a for each loop. And then I'm also going to call it a range-based loop. And I want you just to remember that those 2 things are the same. Some languages actually support the word each. And they stole this from Java and C#, by the way. C++11, the version invented in 2011, provides a specialized version of the for loop that simplifies array processing. If I wanted to print out the data in that heights array, which we never did, we could do so with a range-based for loop. And I'm pretty sure I demonstrated this. The syntax for it is for something colon something else. So instead of x equals 0, x is less than something x plus plus, the syntax is a bit shorter. Let's print out our names. If you've already uploaded your program, who cares? This is just to demonstrate something. For, what what data type is our names array? What are we storing our names as? They're strings, right? So for every string in the names array, cout that string followed by a tab, and then at the end of that shebang, cout an end of line. And I seem to be getting some kind of, no, the error went away. And then just repeat that code for the heights. Except the heights is not string. What are the data type of the heights?
Doubles.
Doubles. So for every double that's in the heights array, cout that double. And then cout another end of line marker. And since we're using the tab, it ought to make the data not look too horrible. Enter the height. Okay, now I've got to do all this rigmarole again. 10 feet, 12 feet, 4 feet, 5 feet. And there we go. We've got a pretty crude table at the bottom of our data showing that Bob is 10, Kelly is 12, Sarah is 4, and Tara is 5. Is that really how I would print the data? No, I would make a vertical list, because what if, we had so many elements that we couldn't contain them on the screen that way. It's better to scroll up and down than to try to scroll left and right. But this is called a range-based loop. Or as I say it, because that's how some languages do it, for each. For each double in heights, print that double out. For each string in names, print that string out. Okay, that's how I say it, but how it's done. For, parentheses, string s colon names. That means for every string in names, copy that value into s. For every double d that is in the heights array, copy that value into d so that we can do something with it. One thing to consider is that these are copies of the data. You can't write something that will initialize to 0 all your data and use a range-based for loop. S is just a copy. You can't change it. Well, I mean, you could change it. You could set S to something else, but it's not going to change your array. So if you need to manipulate the data, if you need to modify it as you're stepping through it, you better use a loop like this. But if you just want to rip through it and print it out or calculate a sum or something like it, that's a great way to do it. Let's put a few more comments in it, and then we're done for the day. Demonstration of a range-based for loop, also known as a for each loop. Textbook's not going to use the term for each loop. Okay, I'm going to go ahead and finish putting in the comments. That was how to copy the array. This was how to get the minimum value in the array. This was how to get the maximum value of the array. I didn't demonstrate summing it, but you already know how to do that from the previous example. Use a for loop, add them all to a total. If all you are interested in is the maximum height itself and not the person that's associated with it, you could get rid of this secondary counter, the index counter. You don't need that if you're not working with parallel arrays. If you only have one array, you don't really care which position it was, maybe. Maybe you do. All right, guys, our turkey is done.